When a MySQL application appears frozen, the most dangerous first question is, which session should I kill? Start with a safer question. What lock-weight relationship can I prove from a bounded, read-only snapshot? In this episode, we will find candidate blockers without exposing SQL text or business identifiers. A waiting transaction and a blocking transaction form a relationship, not a verdict. One blocker may have several waiters. A session at the head of the current chain deserves investigation, but that does not prove it is defective or safe to terminate. It may be completing an important transaction, protecting consistency, or waiting on something outside this snapshot. Our collection contract reads only two performance schema tables, data lock weights and data locks. It returns at most 100 current relationships. Thread and transaction identifiers are transformed into irreversible SHA-256 fingerprints, so rows can be related inside the snapshot without revealing raw identifiers. The result excludes SQL text, schemas, tables, indexes, accounts, hosts, addresses, and business data. The read-only account needs select access to those two tables. If performance schema is disabled, the result says so. If access is missing, the database should reject the request. The correct response is not to expand privileges automatically. This is synthetic output from an isolated test, not a customer system. The first two fingerprints show who is waiting and who is blocking. The transaction fingerprints let you distinguish different transaction relationships without publishing raw IDs. Lock type and lock mode describe the requested and held locks. If several waiting fingerprints point to the same blocking fingerprint, that blocker is a useful candidate for deeper review. But the output is a current snapshot. It does not include SQL text or object names, so it cannot explain business intent. The same contract returned one synthetic relationship on isolated MySQL 8.0.46 and 8.4.10. MySQL 5.7. Production and customer environments remain unverified. One snapshot cannot prove the root cause, the age of a transaction, the cost of rollback, or whether the same weight persisted before and after collection. It cannot tell you that an application is wrong, that an index must be added, or that a blocker should be killed. Those decisions may require repeated bounded snapshots, application context, transaction ownership, deployment history, rollback planning, and explicit production authority. Stop and contact the system owner if observation requires permanent privilege expansion, if data must leave an approved environment, if customer diagnostic authority is unclear, or if someone requests public SQL text or identity fields. Also stop if anyone asks for a kill, commit, rollback, configuration change, or index change without impact analysis and a recovery plan. Evidence collection should reduce uncertainty, not create a second incident. The practical sequence is simple. Collect a bounded snapshot. Confirm the relationship. Preserve the evidence. Then decide whether you need continued observation, a fixed scope database health review, or a separately authorized remediation. The reviewed SQL card, synthetic sample, version boundary, and stop conditions are available on the canonical SQL guide linked below. See the relationship first. Change the system only after you understand the impact.